Hello, folks, and welcome to the latest in the No Fluff Just Stuff virtual webinar series. As you know, every week we dive into a new topic with one of our experts, and this week our expert is Rohit Bhardwaj, and we're going to be talking about cloud integration patterns with data. Rohit, how are you? Welcome.
Well, I'm excited to see everyone here, and this is one of my passionate topic. As you know that one of the things which we always think about is that we have to just apply an EIP pattern. Okay, this is a transformation pattern. Or you apply transformation, everything will work. And really, that is true. But one other thing which I've realized in the cloud is there are some misnomers. We can call it like fallacies. Um,
Sure.
when we work, when we actually do the work, we find big companies like Coca-Cola. How are they handling these kind of situations? Big companies like who are Amazon, like how are they tackling the similar kind of problems, which is a typical way we used to solve it. Maybe we start thinking a little differently about them. That's where it springs. Now the fundamentals are still the same, like we are still talking about the enterprise patterns, but also looking at from the perspective of not just what's the best practice, but looking at what's your use case and then trying to solve it.
Now, what's really interesting is you and I both are going to be talking about similar topics. So, of course, this week we're diving into these cloud data integration patterns, and next week I'm going to be talking about sort of a different approach to data integration. So, it's going to be interesting for folks who are coming this week and coming next week to sort of compare and contrast. And so I'm interested in this as well, just because this is an area that I am thinking very deeply about.
Nice.
Well,
That's good.
and just as a reminder for folks who are joining, we try to produce these webinars every single week, and they're free to the community. We want to, it's just part of our mission at No Fluff Just Stuff to, to really improve the level of software development, improve the craft, improve the discipline, and we all get better and stronger as a result. So certainly, do sign up to get updates on webinars as they're announced, and you can always find these at nofluffjuststuff.com. But if you want more, if you want to dive deeper, or if one of our presenters really resonates with you, or a topic really resonates with you, inevitably we are also offering bigger deep dive workshops that are hands-on, they're live, they're instructor-led. And I say live, I mean the training is live. Of course, the format is virtual. And we do about 15 to 20 of these workshops every single week, or every single month. Sorry, that's a pretty high cadence if we're doing them every single week, but about 15 to 20 every single month on a variety of topics. Right now, if you go to nofluffjuststuff.com, you will see the lineup going through the end of the year. And of course, you can jump into those a la carte, but right now there is an insanely good deal going on. I think it's 70% off of everything. So if you sign up, you get access to all of the courses. Of course, it's all you can eat, but if it's too much for you, and it probably is, one of the great things is you can share that seat with your team. So you can go to the ones that you're interested in and share that with your colleagues. And that also gets you a free ticket to the third No Fluff Just Stuff virtual tour stop, which is an entire conference over 2 days. And again, in this live instructor-led immersive format. But enough about that. I want to dive right into the content. So, Rohit, why don't you go ahead and kick this off?
Awesome. So let me just share my screen. 1 second. Right. Welcome, everyone. So we are excited to be together. First of all, Friday, and getting some time off for yourself is very important. And we all integrate. We are all integrating with each other. We are communicating, making sure. And this session is kind of like more of like a talk in terms of like what we think are the kind of general patterns which are emerging in the cloud industry, not just related to one particular industry, but overall, like how the industry is shaping up with this pattern. So some of them we will be discussing in today's talk, and of course, one of my passion is to look at your perspective of the same thing and seeing that, hey, how are you solving the problem? So what I would do is I'll first go over quickly like what we're going to discuss in today's talk. We will talk about enterprise architecture as a whole, and we'll look at like different components in that, and looking at holistically, like 10,000 feet above ground, like, oh, what could be there. But then we really look at the microservices and what could be an issue in microservices, like what kind of problems we could face in microservices, some elements of resilient architecture. And then when we talk about enterprise architecture, we cannot build everything ourselves. We have to be a core in what we want to do. We don't want to build as part of our solution something which we can get out of the box, or we can integrate with others. For example, if you're not a CRM shop, let's buy a CRM software, for example. Same thing is true with order, like order management. You would want to have someone else take care of that logistics part of that problem. So one of the problem which we always face is that we try to solve too much at the same time. So, and that's what we'll be discussing briefly about, like kind of the topics which we're going to do later on. And in my session, I'll go over in much more detail in terms of, like when we say, oh, we need to integrate the systems. One of the issue which I find is that, yeah, you want to integrate the system, who is really the source of truth. And if you're doing single direction with source of truth, that's perfectly fine. That's the awesome deal you get. I dealt with some systems where they want bidirectional sync going between the two systems, and what happened if they collide. We'll discuss those, like in my session, because we would not get much time drilling on some of those topics. And then at the end, we'll look at master data management, MDM solutions, and looking at from the perspective of, when you have a data, that data is not residing in one place. That data is residing in multiple parts of the system. How that cohesively work, and you have a clean data at the end of the day. That's what we'll be discussing. So today is just a quick overview of what I'm going to discuss in my session. I think it's a 4-hour session, so you're welcome to join that, and we'll discuss more in detail. All right. So let's talk about enterprise, architecture. I mean, everybody might have seen similar kind of diagram, like oh, I have a sales and marketing, where I have channel management, lead management, sales force management is there, or I'm doing customer interaction. There's a finance, business intelligence is getting all the data from us. So important part which you have to understand is that each of these systems, each of these blocks, accounting, billing, customer management, order entry, these are different, you can call it systems. These are different microservices. Yes. So even if we in our land are building our own gateway, a portal, that portal we are building is a microservice. Behind the scene, we have to see whether it's a microservice or not. Behind the scene, we have to make the decision in terms of, oh, whether it will work within the infrastructure layer which we are looking at. Now let's take a look at our nice microservice we just wrote. We excited, we wrote the microservice. Now we want to ship it to the world. We said, okay, ship it. Now what would happen when we ship that microservice? And the question always comes in, yes, I can ship my microservice, but this microservice need to interact with a distributed app which is in public cloud. Not only that, it has to interact with private cloud. So what could be issues? What are the issues which we can find in this? That's what the question we are trying to ask ourselves. We want to ask ourselves, we want to ask these questions like, hey, if I'm building this microservice, yes, I'm using Docker container, I'm using all the latest technologies, but who's calling me, or who I am calling, so that we have a clear understanding how to do it. So whenever we build a solution, we have to look at private, public, cloud, and infrastructure where we are calling in. So that's not all. What we need to see is, where are the vulnerabilities? The vulnerabilities can be like, flying blind, like, the users can be there. They can be a throttling going on. They can be latency attacks going on at the same time. So we need to be aware of this. We could have an insecure asset through the trust boundary, or we could have like, silo applications limiting the use of it. Now, that said, the important thing is that why are we talking about it? Why does it matter to us? That's the question which I ask myself. So for that reason, let's take a look at some microservices issues. Like, when I ask the question, like, hey, what kind of issues do you find in microservices? And Michael, like, can we ask questions, or is it open forum, or is it people can respond, or not?
Well, right now I've got I sent a message out in the chat that
Mhm.
this is a good place to go ahead and throw questions in there, and I'll moderate. But
Okay.
of course, we're pretty flexible, and if you want to unmute
All right.
and ask a question directly, that works too. But this way, we can kind of structure it a little bit, and
Yes. Yeah.
because we've got a limited amount of time.
Sounds good. Perfect. So actually, what I'll do is I will go through the slides, but I will try to ask you questions, and you can put in the chat window your answers, whatever you think might be the right solution, whatever you think about, and we can combine and see, what makes sense for us. So when we say microservices, we all know microservices is a great pattern to use. I know, there are a lot of good things in microservices as a whole. But let's take a closer look at it. How is it really working? So let's take a look. End user is calling through a mobile device. They're calling a microservice. Basically, they're calling an API. They're calling an API through some gateway. Let's call it API gateway. I'm calling this through the API gateway. Now I need to call this microservice. That microservice is dependent upon these two microservices getting the data. Oh, this also depends upon this. And by the way, this microservice, sometime it calls. Okay. So what's really happening here? So what do we need to do? Like if you think about and use a use case in this case, like, end to end, when we are trying to build our application, we are trying to build these resources, API resources. Yes. When we build these resources in the microservices land, like, how the end users will be processing this. That's the question we need to ask ourselves. Now, one of the ways you can say is that, oh, I have this microservice. How about this microservice gets the values, and it sends wait here till all of these APIs respond? Probably not a good idea. Yes. So what can you do? What can you do to protect yourself? That's the question which I have. Initial question to start with. What can you do to protect yourself in that case? So one is that, you can have a 500 milliseconds or 1 second response time or 2 second response time. But if you're looking for end user, you're looking for a blink of an eye, which is a 250 milliseconds response time. Yes. So what do you think we can do in that case? We can take an approach where you can use streaming. So Sanjay is saying we can use streaming. Yeah, you can use streaming the data. The data will be streamed, and you can process the data. That you can do. And caching is also possible. Ibrahim is saying caching. Yeah, you can do caching because what happens, like, when you're getting these records, you might cache them and then process them as it goes. Or if this API is actually a value which is a name value pair, you can save it in 5 minutes interval. You refresh this cache. Yeah, that you can definitely do. Absolutely. We'll
One of our
involve cache.
esteemed
Mhm.
participants here in the audience, Mark Richards, taught me the concept of data domains.
Oh yeah, domain driven design and data domain. So Mark, like, he's god of this structure. So microservices his lands. I mean, he can teach the whole topic here. Yeah, absolutely. Mark talks about the same subject. I face the same problem. I started creating these microservices and they're calling each other. Problem is not creating microservices and databases along with them, because each microservice is independent database by itself. The problem is when we start interlinking between these microservices, it's as a base, it looks really cool. But in order to solve that problem, one thing which I could do is I can provide, asynchronous call. I can say, I can respond back and saying that, okay, you have received your order. Just like Amazon can say, oh, I have received your order. We'll process it and let you know how it goes. You would not be processing it at that moment and calling all these microservices and the APIs which are there. And then a downstream communication between the services and the request can take place asynchronously without any problem. So that's like one easy way to solve this problem. Yes. But let's take a look at Amazon.com example. Same thing through Amazon.com. So what's really happening, the user is making an online store call. When the user is making an online store call, what's happening? This has to be synchronous. Yes, this has to be synchronous, and I have to put it in the database, this value. The user is saying, okay, I want these 5 items. Amazon has to pick all of them in. So when we create a synchronous system, what's really happening? What is the drawback of creating a synchronous system? So what happens is a microservice is explicitly persist the data. Yes. So what you can do is you can persist the data here. So whenever some requests come to it, it's going to first persist that data immediately after receiving it. Yes. So when you receive the data which is coming to you, you're safe then. Now, if something goes wrong, you're still fine. Yes. I mean, that's one way of putting it, load balancing. Yeah. That's where I was about to go actually. So J. Lichtman is saying absolutely we need to have multiple node redundancy and load balancing. Absolutely, all good stuff. So basically, by some means, microservices need to put the data in the database somewhere. Yes, and before it is there in some persistent layer, now then we can say, okay, this is resolved. But wait a second, is it really resolved? Let's talk about this from a different perspective. How would be that complexity looks like? Let's think about that. Amazon.com, the customer is coming in, it's sending the order here, that order is getting processed in this one. What are the problems which can occur here? You can get overloaded. Yes, you can, infrastructure will be very complex. So let's talk about this. So let's take a look at what would happen in the backend side. We'll have a web server I need to create. I will have a load balancer here. I'll have a web server. Not only one web server, I could have multiple web servers here, which could be there. And then the HTTP requests will be coming in, and we have to implement that particular solution. The load balancer in front of it, and backend also has to take care of it. And decoupling of the services APIs have to be done. So decoupling means now this API is calling this API, and that is calling some other API. You think what kind of problems can occur? Just think about it. We'll talk about exactly. There are 8 issues which can occur. I'll talk about them. But you start thinking in your mind what those are. Okay. I'll hold on your thoughts on that one. And why I'm saying, there may be an issue here. So, okay, let's talk about it. Another issue which could happen is what could be another issue which can happen here? Like, when we are working out, let's say you getting 100 calls. You started getting all of a sudden 100,000 calls. How are you going to solve that? I think Jlitter is going in the right direction for that one. Like, you get just getting 100 calls per minute. Like now you started getting 100,000 calls per minute. So what can you do to really solve that problem in regular way? Like, because we need to solve this, because we all face this problem. Like load balancing, you have to load balance each microservice. You remember that. It's not just one microservice you have to load balance above. No, you have to load balance. Each microservice has to be load balanced. Is that a good thing? Probably it's a good thing because it's a customer facing. We have to balance that. But absolutely, he said that, yes, this, I agree with him, like, on this one. So what's really happening here? Think about it. I added the auto scaling group. So when I added auto scaling group, what happened? What is the first thing that will happen? There will be a latency scale out. Yes, whenever you have a latency scale out, what would happen? You're not going to request it right away. Whenever the scaling threshold is there, if it is not optimal, you're going to start getting HTTP status code 500. You're going to start getting problems here. So what is the solution? Like, how many servers can you have? Like, let's say you get 1 million calls in 1 hour. What are you going to do? And these are orders. You have to support these orders. You can't say, sorry, come back later on. Like, whenever I have time, I will process it. Amazon never do that. Amazon will take our order and think about processing it some other way. So basically, so that's the problem. And then also the question which comes down is like, how to solve that problem. Any thoughts on like, how to solve this problem? Do you have a latency issue here? You have to fix the latency issue. So that's another question I have to ask myself. Like, how am I going to solve this problem? This is a typical problem. We all face this problem. Now, okay, you can say that, oh yeah, that sounds good. Should I design for peak load or should I design for average load? That's another question. Lifecycle management. Yin is saying lifecycle management. So when you say lifecycle management, what do you mean by Yin? What do you mean by that? And you're saying lifecycle management in this case. So you are processing the records, the microservices calling another microservice, calling another microservices. So many applications have latency, different status for each event. Yes. So you can do order accepted, order processed, order paid. And that is a thing customer can ping. Oh, what is my status at any given time? They can ping that value. Yes, absolutely. That's true. But in that case also, the order service has a limitation. Yes, order service at any given of time, like like for example Friday, like Thanksgiving Friday is there, you're getting million requests per minute. You're not ready to process that. Offline state management synchronization between the availability based on load. Yes, you are moving in the right direction. So Sanjay, yes, you are absolutely correct. So one other thing which we have to look at is like how to handle these steep which are coming in. You have a steep coming in, you have to think about different ways to look at it. Absolutely. You could look at Lambda. You could look at some other way to process the same record. Okay, if you're getting million records, you put it in S3 and process them through Lambda function and then put it into DynamoDB if you want to do that. Yes. So that could be one thing which can be done in this case. So the whole point is not to overwhelm the architecture. So that's the number one principle for everything what we do. Never overwhelm the architecture. So whenever we say, oh, I have to do load balancer, but what's the limit for it? What are you designing it for? You're not designing it for the sky. Yes, you have to have limits there. You have to have throttling there and things like that. But ultimately at the end, you have to process those records. So that's where we will look at, some ways of doing it through SQS, and see, how can we use that along with the microservices to solve some of these, problems which we get, the flood attack which we get. So whenever there is a flood attack, we can handle that through some mechanisms like queues and SNS and things like that. So that would be on-demand stateless container processing. Yes, absolutely. Yin, you are moving in the right direction. Absolutely, I love this. But before I do that, I wanted to give you a good overview what really happens when client is calling network, which is calling a server. Okay, let's just think about it for a second. I have a client. This is pretty much any REST API call. Any REST API call will have the same problem. The reason I wanted to talk about this is we need to know what places it can fail. Oh, it's just a REST API call. I'm doing a post request. When the post request has been done, network is calling in, then network is calling the server, and server is then receiving that message, then replying for that message, and that message network is replying back to the client. This looks very simple to me. What's the complexity? The complexity is right here. So whenever a message is being called, the client puts the message into the network and delivers the message. Server validates the message, server updates its state, and if necessary, based on the message, if there is problem in the message, yes, you're saying not accepting that message, and then post reply, the customer reply back that message. Now all these things are good. we are able to do that. Yes. Yeah, that's true. So absolutely, that's true. So absolutely. So what we are trying to do is, what we need to do is, in this particular case, is we need to look at different areas where it can fail. All right. So I would not go over all of them. This is just for a reference, like, why this is important and why we need to do the retry mechanisms to really solve this particular problem. But it's all these areas can fail. So now, if it fails, we need to, as part of our, he's talking about high traffic. Um, Yeah, yeah. Absolutely, you are right on that. So I think Parag, I think he's talking about how many petabytes of data is coming in the Prime Day. It's mind-boggling how they are solving this problem, how they are really solving this problem, and literally all these issues are still there. Retry mechanism they are doing. They are doing fatal injection, like, they are unhandled exception. They are doing all these things. So Akade has absolutely saying the right thing, because these are all the queries, these are all the latencies. And believe me, 10 years ago, they did the test. If there is a 1 second latency, Amazon.com, they actually lose 10% of their sales. It's like during that time. So it's like a big impact which we get out of it. But that's all good. Like, this is all good to know, like what we need to do. Absolutely. Now comes is, how do I build a resilient architecture? Yes, I wanted to build a resilient architecture. It should stay forever, like, and we are all familiar with the nice way of resiliency. We are all familiar with this. It's nothing new about it. Resiliency, basically, it's an ability for infrastructure. For any disruption it comes in, I should not know about it and it should solve it. Yes. So I don't need to worry about this. It should solve by itself. And that's where, the resiliency comes in. And responsive means like 250 millisecond response time, 500 millisecond response time. How am I going to achieve that? Through message driven, we need to achieve this, and through elasticity. And we talked about elasticity, how to do that. So now let's talk about another way of looking at the same issue. I'm going to go back to the microservices model, which we just looked at. Okay. So what we have is that I have a unicorn Uber. So I have a Uber service. Okay. This Uber service is actually getting the rides for me. And that has a Uber management services there, which basically storing all the rides. We talked about this, by the way. Any API comes in, I should store it somewhere so it doesn't go away. Like, if something goes wrong, I should be able to do that. So what are the requirements? Like, what do you think would be the requirements here? You have a customer notification services there, which is right here. The customer notification service is basically should receive the notification about whenever the completed the ride. It's not interested in a ride which is going on. If it is completed, then only it needs to know about this. Accounting services there, where some service is responsible for collecting the fare. So this has to be done like right after um, the cab has come in and it has dropped us, not before that. The customer loyalty program is there, which everybody wants to collect the miles, like, how many miles you're getting. You get the idea. So how are we going to solve it? Like, how are we going to solve this problem? Any thoughts? Like, how should we solve this problem? I just have a REST API call. I'm calling the API gateway. Let's say this is an API gateway. I'm calling this API gateway here. I'm storing all my rights from that API gateway. And what do I call for these REST APIs? How can I do that? How can I solve this problem? Any thoughts? Logically, these looks like microservices to me. Yes? Okay, yes. Another is saying pub sub, is saying pub sub. Yeah, that can be done. Yes. So effectively, like, there could be many solutions to this. I'm not here to say, okay, this solution or that solution, but one solution could be you can create a REST API calls. And these are all the APIs which are there, which we have to manage. It's perfectly fine. That's one model which we can have. And this basically, it needs to store all the right data. So If any of these could not take the data, it should be able to resend that same data. So that's where the pub sub could come in, and maybe we can solve with that particular problem. Another thing is that like we can put a distribution service in between. Like, we can say, oh, you send it to this service. This is responsible for basically sending the data to all the places where we need to send the data. That could be another way of looking at the same thing. Another way is, you have a self-managed service, like, where you're saying, okay, I have these filtering mechanism, like which are there, and it's going to call these APIs and be able to solve that particular problem. We can do that, and all these things have problems, by the way. Like, if you have a REST API route, which we may have to do REST API, but what could happen if this is sending a request to here? This could fail. So I have to resend it again. All those issues can come in. So what can we do here in this case? Absolutely, we can do pub sub here. Yes, which is absolutely true in this case. Now, what I'm doing is, okay, so I did the topic. I published that topic out. That topic is published now, and then I'm saying pub sub is been published, and this customer notification received, all these received it. So now that's good. That okay, I can use SNS. Like I can use here SNS or Event Bridge. Like Event Bridge is another way of connecting Amazon, or you can use any other way of pub sub. Doesn't matter how you do that. So what it's doing is sending me the data, and this is getting processed on this side. Yes. So what could go wrong here? Any thoughts? What could go wrong here? First thing is that, depending upon where I need to go, I'm only interested in not all the data, but only the data which I'm interested in should be there with me. Yes. So I need to do the filtering. Yes. So first thing what we need to do is we need to do the filtering of the data. That means the SMS message is coming in, discard the irrelevant message. If there is a relevant message, if it is more than certain distance, like, or certain rights is there, you discard the message right there. Don't even send it to that delivery thing if you find. So by the way, SNS has that. Like SNS has a filtering mechanism which you can use to really do this. But the problem is still there. Like I got disconnected. This is SNS. Now SNS is sending the message out. What is wrong in this architecture? What's wrong in this architecture? What do you think could be wrong here? I have this accounting service here. This accounting service is running really fast because doing credit card processing. That's fine. But I have a customer loyalty service running really slow. This service is running very, very slow. Data lake injection is running really late and not all the time also. So one thing we have to keep in mind is that we have to look at in PubSub also. We need to look at what rate the people are consuming it. Yes. So in that case, what can we do? We can correlate the messages. Absolutely. We are right on dot on this one. So this is true. So we need to add this. So we need to add a topic queue chaining pattern. Like we have to add a pattern here basically to chain the messages out. So basically the consuming service will consume. So even if it goes offline, it's perfectly fine. It will resend the data out, and you can replay the data also. Let's say if you lost the data in this one, it come back and say loyalty service say, okay, I was down for 4 hours, give me back the data. Now I can just use this to process my data. So that's where the SQS really helps. It basically acts as a buffering load balancer. It's better than load balancer, put it this way, in a different terms. Now there are certain things like you want to do how fast you want to run it. SQS, if it's like till 3,000 messages per second, it's fine. 10,000 is fine. But if you want to do more, you have to use Kafka, or if you want to use Kinesis Stream to really solve that particular problem. But you get the idea. Like what we are trying to do is look at the use case and solve it. Okay, so let's take a look at differently. Same topic, I'm going to talk from a different angle now. Okay, linking multiple applications. Now you are building this application, one application calling another application calling another application. Now think about these are disparate, different systems. Their systems are all clubbing together. They all need to work. They all need to talk to each other. It's not like one person talking only to one person. Accounting needs to talk to billing, needs to talk to customer management, needs to talk to order, you need to talk to inventory. And if I ask an enterprise architect, how are your web services connected, APIs connected? You know what they're going to tell me? They're going to show me a diagram exactly like the one I'm going to show you now. And try to relate it to yourself. Like, do you think you have the similar diagram or maybe a different diagram? Like this. So I laugh at this because, this is so true. Like, this is what the ESB is like, it's just hiding all this complexity from me. But really the problem is not that. Problem is that if I need to fix something, I don't know where to fix it. If there is a debugging problem, like, it's tough to fix these kind of problem which comes in. So a level of abstraction is really good to have. And that's what we're going to talk about in a second, like what that abstraction looks like. So basically the question is, how do I basically do the design for the workload? So when I can design, the client is calling the internet. I can call to the CloudFront, to Amazon API gateway, which is now connected to a Lambda function, to the serverless microservices, or through EC2 instance or ECS through containers. Both are perfectly fine. Now, the advantage of microservices through serverless is that we don't pay for it if we are not using it. So that's one of the bigger advantage we get out of it. Now, again, I come back to the same question, AWS question. Now I got my server, I got all the requests. Now I got SQS, I put it in right away. That request, now I need to send that request to inventory. Yes. What AWS says, don't send me do not send me. I'm going to pull the values. I'm going to pull the values. So that's what is sometime, beneficial to solve the same problem, whatever we discuss right now, through CQRS. So command query responsibility segregation, where I'm persisting the microservices data and publishing it to the event. And now that can be pushed to a bus. When it get pushed to a bus, you're all set. Who is consuming then? That is none of our business. At the end of the day, we just got the commit log. That commit log will replay at wherever it needs to go to. So that makes it a little bit easier. It helps in the UI also, because the response time of 250 milliseconds, really good. It also helps in connecting the data for us. Now, I know that we all know about this one, but the question which comes down is that this queue, when I'm sending the values from the queue, one of the issue with the event bus, big issue with the event bus is that it does not guarantee the data to be always there in a sequence. Yes. So when the data is not in sequence, how are you going to solve that problem? Say from the producer, I need to send it to the consumer. The data is there. How to solve that problem? That's a problem we need to solve. Like, let's say I'm creating an order. When I create an order, I did airlines booking, and I did book. I also booked at that same time hotel. And then after I book both of them, then I'm purchasing that same thing. It has to be, transaction has to be in the same order. Yes. How to do that? How do we do that? Any thoughts? How can we do this? Like, yes, we want to do pub sub here. We want to stream the data here. Well, what do you think? What do you think from your perspective we can do to solve this problem? Any thoughts? Order can be in a message, yes. Or response, delivery, receipt coding. Yes, you can do that. You can do response and delivery receipt coding also you can do. See, all these things, extra things we need to do. Kafka with train ID, transaction ID, exactly. So that is where we need to look at the transaction ID. We need to look at the replay ID. Think in terms of the replay ID. Whenever I have a transaction, I have a replay ID associated with it. And then I have a transaction also associated with it. For a given transaction, for this transaction, you have to replay 3 events at the same time in that same sequence. If it does not happen in that same sequence, don't take it. So that's where, the sequence ID comes in also. Transaction ID can also come in, and also sequence ID. So that means when the customer receives it, they're going to receive 87654. FIFO, exactly. So FIFO queues has issues. If when you are doing FIFO queues, if it's like 300 per second, it's fine. 3000 is fine. If you want to do 1000 per second, it's a problem. Like 10,000 per second, there is a big problem there. So for that, there is a different pattern we can think about using. You cannot do FIFO right away. So you have to do it differently, like that particular problem. But yes, that's absolutely true. Standard FIFOs are there, but standard FIFOs would not solve the problem for like yes, batching with FIFO. Yes, yes, yes. That is something which you can do. NQ also you can use here. For that purpose also you can use it, but you have to be careful. Like you cannot go beyond your capacity in this also. So you have to make sure either you put it in S3 or a bucket, and then you take it at a time, or put it in Kinesis stream and then take it at that time. So that's where you have to see what's your capacity looks like. If one consumer is really fast, they're going to take these two data and process it really fast. This consumer is slow, it's going to process it slow. And there's a sliding window which is there for 36 hours. So any consumer can get that data within that time. So that's what is used in Salesforce. Like, we use it heavily, PubSub model, we are using it. And it's very, very useful from that perspective. Now I'm just changing a gear a little bit on this. So this is basically, I am doing, what do you call that? Flight booking. I'm going from Boston to Chicago. When I go to Boston to Chicago, what happens to the airlines? American Airlines, Delta Airlines, and other airlines are coming through. What if they take more time to retrieve the data? It's not good. Yes, they would not be considered even. If it takes more than 5 seconds or 3 seconds, the program discards them. So you cannot really do that. So that's where, the important thing is, from asynchronous perspective is one thing, but you have to have data in the format which needs to be consumed by them. So consumed by someone. So you need to have that in a JSON format. The star schema need to be in a JSON format. That's what I'm trying to put it here this way. So we all know CAP theorem. We cannot solve all three at the same time. So some people may ask like, oh, yes, I know there's a CAP theorem there. Like, it's pretty easy. Like, you can either do consistency, partition tolerant, you can do it. The problem is that if you go to consistency, if it's a terabytes of data, you can't solve it anyways. You have a replication lag. Any SQL you write, you don't know how much time it's going to take to execute it. So that means when you're processing these records, you have to take the transactional data, raw event source that data, put it in Cassandra. Now we are ready to go for our customers. Now I'll show the exact same diagram with microservices. You think like that, okay? You get a microservice here. That microservice first puts the data into some stream, and that now get consumed by different microservices. I'll show you exact same diagram again, this diagram. So when we are building the centralized store, critical references of the data needs to be created. For example, like when I'm building a centralized store here, this is where I'm doing Kinesis Firehose stream, because when the data is coming to us, it has to come really, persistently. Microservice has to be fast also. So whenever it gets the request, whenever the API gateway gets it, Lambda is going to push the data into Kinesis. Now it sends the response back. Yes, I'm processing your request. Order is being processed. Now AWS goes in, looks at the Kinesis Firehose. Millions of records are there. Petabytes of data is there. It put it in S3 and then processing that through Redshift or thanks Mark, for your comments on this. Yes. So the point is that we want to solve this problem, and this CAP theorem is just for the help of like what we are trying to do. But you think about, these were the three services we were calling before also, but now I'm getting it from Kinesis or Firehose. Because I'm getting from Kinesis, it's saying the transaction ID is coming through, same pattern is coming through. Now that all is good. Like, this is all really good. CQRS is really solving my problem in this case. But the question comes is like, I have different discrete systems. I have airline booking, I have hotel booking going on, I have some other booking going on at the same time. How do I do the saga pattern? How do I do saga pattern? Yes, I mean, we do saga pattern, some other place, like a monolithic application when we are building it, like, cap theorem is there, like, sequence of the cap theorem, like distributed database is there. You can use, in that case, step functions. Like, if I get time at the end, probably not today, I will show you some examples on this. Basically, I am creating a pattern of different lambda functions. These are different microservices I'm creating here to solve the same problem. Cancel flight is one of the microservice, lambda function is there. And I could call here a container service, doesn't matter what I call. I'm calling an ARN, and at any given time, I can say that, okay, you can apply a saga pattern to really cancel the hotel booking for what you're trying to do here. So that is another way of looking at the same thing. We'll talk much more in detail about this, but you think about AWS step function, you could also use as a saga pattern instead of doing it, doing it the microservices like component way, right? Because the data is not in one place. That's another problem. Hotel booking is in one database. This is another database. How are we going to solve that? Like, common database will not solve this problem to begin with. That's where my last one, MDM solution, comes in. And you know what? When I say MDM solution, master data management solution, we have to be very responsible, very, very responsible. How my data is flowing in different systems. It is flowing in different systems. It's going to services, going to sales, finance, different system it's going to. We need a way of identifying the producers and consumers, the way I talked about before, collect and analyze the metadata, how it looks like. And some data stewards should be there. Somebody should be responsible to say, okay, this is the way we're going to govern the system, design the system. And duplication, we have to remove the duplication also. When we do that, we basically are creating data dictionary, taxonomy, lineage, and classification. We'll go in much more detail than I am throwing at you guys right now. But the whole point here is what we are trying to capture is ERD diagram in our terms, hierarchy of relationships, and how my data is flowing from one origin to another origin, and what is my classification of data looks like, what is my security control looks like for me. And that is at a high level is MDM solution, which basically gives me an understanding. If I have 20 systems to connect to, and 20 systems have customer data is there in legacy CRM, ERP, this and this also. All those data, whatever data we have, there need to be some place where I can go and make sure everybody pull from there. That's what the MDM solution really helps us out, solve that complicated problem of, like, it's not one system we are dealing with. So there are three things which are important here. Number one is golden source of truth. When I single source of truth means that MDM solution will get all the data, single source of truth. But sometimes what happens that these are different systems. I said that HR system will have some user data there. Those will be system of records. Each of them will be having system of records, and they all will be pulling the data through data flow. Data is flowing into the system, and we are getting that. So think about the complications you can get into, and we'll talk about the complications. Like, there are a lot of complications which you can get into. Bidirectional syncs, correlation IDs, there's so many of them. So at the end, what's happening is system of record in the CRM, which is there, it only has some data attributes. CRM has these names. Order has a little bit more information. Product has a little bit more information. Now I can collect all the data and put it in the master hub. Any system wants it, I can get that data. It's an easy way of connecting and using that particular data. So solution wise, we talked about it. The problem which always comes in is the data needs to be clean. That's where the data strategy comes in. I'll have a separate talk on data strategy, how to do the data strategy, how to do data management, data matching. You have to match the data, probabilistic matching, what kind of different matching could be there. You can have. Basically, you are asking yourself in data governance the same kind of questions. who uses this data, why is the data used, which data is used, how is the data used, and what is the data quality looks like. Looking at that, push it through, comes like elimination of duplicates. You're cleaning your data and you're processing that data. That's where the stewardship comes in, which does all these activities at the end. So the important thing of the governance is we want to get the stewardship done for us. So this is a really nice thing to have in place for the systems to look at the data and say, oh, is there any duplicate records? Fix them, things like that. So that's where the policies comes in. That's where people at executive level will look at something different. At tactical level, we look at something different, and we at a developer level are looking at something different at the same thing. Same kind of data is there. That's where the data stewardship comes in, where we look at any data which is coming to us from the perspective of GDPR. When we say GDPR, what does it really means? It's the consent. Give free consent. Yes, I let you use my phone, but at any given time, I can ask for delete my data. Legitimate purpose should be there, and after that purpose is done, you should delete the data. The data, we should be accountable for deleting the data. How to secure the data. GDPR is there in US also, because California laws are being published. So when I talk about this, if your company is only in US and they work in California and other states are coming in too, you should look at this, and we'll talk about more like how to look at the data, what are my rights looks like, how to get the data from me. That said, the important thing is, what's my personal data which is still okay to be shown little bit. Well, what's the sensitive data looks like, and health related data and other data looks like. And we'll look at some patterns to really identify issues, how to do this. And of course, you also need to have a data retention policy, till how long you're keeping that data, you're classifying the data, things like that. So today, we discussed, a lot of things right now. I just want to get any questions you guys have, so far, and, want to just see, what people think about this talk, or what else do you want to see in this? What are you really interested in? That's what my real question is for you guys. All right, any questions? So floor is open. Mike.
Absolutely. By the way, great stuff. Thank you so much for taking the time to share your knowledge and expertise with us. And just to echo that, yes, if you've got questions, feel free to throw them into the chat. If you feel comfortable, go ahead and drop off mute and throw that out. We've got just a couple of minutes before we wrap the workshop. And while the questions are formulating, one more time, I'll throw out the reminder. Head over to nofluffjuststuff.com and check out the upcoming deep dive workshop into this topic and a whole host of other topics. Those are about 4 days a week. 15 to 20 of these happen a month. And once again, there is that incredible opportunity. In fact, let's see if I can do this.
Right.
Aha. So if you can see that, this is nofluffjuststuff.com. We've got the flash sale, incredible deal going on right now, as well as the upcoming conferences. Everything this year, of course, is virtual, but it is the same great experience that you've come to expect with No Fluff, Just Stuff. And literally that, no fluff, just the stuff that you're here to learn. None of the sales pitch, the vendor floors, anything like that. The virtual workshops coming up. These are the next several. And of course, if you've missed some of the webinars that we've done in the past, there are replay links to all of the webinars that we've hosted. There are a great deal of these in a huge variety of topics. So definitely take advantage of that. We've got some questions coming in. First of all, more kudos to you, Rohit. So thank you for that. Arcady says, great seminar. Thank you. And Ibrahim says, regarding GDPR, what can you do if you can't delete the data? Is it okay to de-identify the data? And that's a great question.
Yeah. So this comes up all the time. Like, one of the thing is that, the data needs to be part of an entity which, so think about differently. Like, when we talk about GDPR, like I'm going to talk about really the design part of it, like the core design at the end of the day. What you need to do as part of your design is that you have something called an individual. Okay. That individual can be your customer. Okay. Okay. The same individual can be your supplier. The same individual can also be your competitor at the same time. So what's really happening is that whenever you say, I want to delete the data for this customer, you have to look at the context, the way which context is getting deleted against. You want to delete that customer data based on the customer, then basically you need a way of only deleting the customer data which is related to that, not the supplier data, not some other data. So think about when you come up with your data strategy, and something which I have done some of the projects on that. One of the important concept here is that you want to make sure that you think of customer as an individual, customer as an individual who can have multiple roles. Like for example, us also, like we have a spouse, we have children's, we have other linkages are there. So for them, like we are acting as something, we are working for a company. Similarly, that's what happens, like when you delete the data, you are deleting the data for the customer, or like which customer is there, which jurisdiction is there. So that's very number one, that's very important thing. Another thing is you need to scrub the data, totally scrub the data, and yes, you can do it. So the question is that uh, uh, further expand, yeah, to yeah, thank you, yeah. So one of the thing I would also suggest is that you can de-identify the data. That is something I have done in some projects, where you can literally not delete the data. Ideally you should be able to delete the data, and there are laws for phones, for emails, for addresses, all three of them. And then you have to ask permission for each one of them. Can I store this data? We have consent or not? So there is a big part in this which is called consent management. So I will touch on that a little bit more in my talk, just to get a flavor of what is consent management. And there could be multiple levels of it. I can talk about more on that. Connect me on LinkedIn, Abraham, I can give you more pointers to this. Right, great nuggets. Okay, great, Shailesh, thank you. Any other question, guys? So Brian saying thank you. Yeah, yeah. Connect me on LinkedIn if any questions. Like I can help you out. Personally, I can help you anywhere. Let me know.
Well, all right, folks. We're coming up to the top of the hour, so we're going to go ahead and wrap it up. But once again, thank you to everybody who took the time to join, and especially thank you, Rohit, for taking the time to share your knowledge and expertise in this area, particularly around the GDPR, because I know in your day job, that's very, very big in dealing with customer data and managing that consent, especially on that platform. So. As always, thank you for all of this. I'm looking forward to the workshop coming up. And for everybody out there, stay safe, stay warm, stay healthy, and stay sane. Look forward to seeing you next time.
You got it. Awesome. Have a good day, guys.
Enjoy. And the weekend, as you mentioned.
And the weekend, yes. And nice snow here in Boston.